Welcome, or welcome back, to Yet Another Retro channel. As you can see, today we're going to be working on a Commodore 64 so that I can try to get some of my very limited Mojo back after a long absence from the channel. So, as many of you know, I've been away for quite a while. I'm not going to make excuses, but just know that I would have liked to have been in the lab working on things and producing videos, but other obligations have kept me away. But now it's time to get back to basics and see if I can't recover whatever I might have lost of my, again, very limited abilities, and see if we can fix a grubby, dirty, filthy Commodore 64. This machine was stored in someone's attic for many, many years, and as a result is covered in dust and grime, which is the reason I'm wearing gloves today. As you might have noticed, I don't normally wear gloves. Apart from being filthy, it looks like it's in pretty good shape. We have all the badging. Most of the printing is still on it. Everything looks intact. But I don't know if this thing is working or not. It may just work. I haven't tested it. I've had it for quite a while. It's been sitting in my to repair pile. And again, it may just work. But we're going to find out. And we're going to do it in as systematic a way as I can remember how. So, let's flip it over and start getting inside so we can do some preliminary testing before we do a try. We have all three screws, but we only have 2 feet. Okay. Now as we crack it open, we've got a crack sound from the clips. We'll check the keyboard out later. And we have, again, a very filthy inside. This is a 250425 board, so a slightly later revision than the 250407s that I usually work on. We have the RF and heat shield. This has tabs that come down and rest on the main ICs that have heat issues, the SID, PLA, the CPU, the 3 ROMs, and the VIC-2. Gonna need a good clean. It's not too bad on the underside, but it's corroded and filthy on the upper side. Now, what do we have? We have... Oh, yep, and I got that backwards. I'll have to remember that for later. On the 250425, the PLA and the SID are in reverse positions. So, a visual inspection. Again, filthy. Not as bad under the RF shield as over the rest of the board. We have a 7701 instead of an 8701 clock generator chip. We have an R8 VIC-2. Not that I would have expected anything different, but we have a 906-11401 PLA, the MOS PLA. A standard 6581 SID. An 01 character generator, an 01 basic, and an 03 kernel. So those are what I would have expected. DIAs, nothing special there. I do see 1, 2 MOS logic chips. And the RAM seemed to be all Texas Instruments. So, before we apply any power, I'm going to go ahead and test a few things. Check the fuse. The fuse is good. Check for shorts on the voltage regulators. No shorts on the 5-volt regulator. That would have been a capacitor charging. So no shorts on the 12-volt regulator. Okay, and see if we have a short on the 5 volts or the 9-volt AC, and I'm not seeing any shorts there. So it looks like it should be safe to power this up. So we'll go ahead and power this up. Now this may just work, or it may not. We'll have to see. Black screen. Okay, black screen. So what I'm going to do is I am going to take this board the rest of the way out of the case, and I'm going to take it for a wash before we do any further work on it. There's some rust corrosion on the bottom of the case and here. So it looks like we may have had some water ingress at some point. Of course, that's the bottom of the board, which is protected by the bottom RF shield. So that may or may not be an issue. We'll have to clean that a bit. Well, not the bottom of the RF shield, as I just throw those away. All right, I have clearly lost some of my mojo for removing these RF shields. However, there it is. And off to the bin. Now, the back of the board, considerably cleaner than the front. We'll give it a quick inspection, see if any previous rework's been done. Right now, everything is looking factory fresh. So I don't think we'll have to worry about any previous rework being defective. Go ahead and take off the port shield. And we will take this thing off for a wash. I'm just going to take it to the kitchen, run it under warm water, use brushes and dish soap to clean it. Looks like we've got some bent pins on the keyboard connector here. And we'll be back with a clean board to work on. See you in a bit. Well, I'm back. Would it surprise you to know it's been over a month since the first part of this video was recorded? I have gotten tied up with other issues and haven't been able to get back to this since then. But the board did go for a wash. As you can see, it's a lot cleaner than it was before. And I actually started working on this a while back. I forgot to record the video, so some things have happened, some small things have happened in the meantime. Once I brought the board back clean and it had, obviously dried, I retested the power rails, and I found out that the 5-volt rail coming from the external power supply was low, very low. So the first couple things you check when that happens are the power jack and the switch. Now, the power jack I went ahead and cleaned with Deoxit and ran the connector in and out a few times. That didn't seem to fix anything, so I started looking at the switch. I did find that the switch was a problem. The original switch, when it was in, was not providing enough power to the board over the 5 volts to allow the machine to work at all, pretty much. So I did desolder the switch and put in a new one. I keep a few spare new switches around. I will at some point go ahead and open this switch up and attempt to clean it and see if I can get it back to operational again before I put it into my spares. So that issue was taken care of, and we started getting better voltage. I check all the way across the board on the user port. These 2 pins on the user port are the 5 volts. The 9 volts is over here on these 2 pins. And I was getting better voltages. So that's where we stand right now. We're getting close to the voltage that I'd like to see. We're actually still a bit low, but it seems to be not causing a problem. We are running, I'll show you here. Plug the power back in, turn on the switch, and show you the reading that we're getting on the 5-volt rail. Well, that's even lower than it was a little while ago when I was looking. 4.5 is not where I'd like to see it. I'd like to see it up at least at 4.75, but we'll see what we get here. And if we look at what our video is outputting, we're getting garbage. And actually, this is not quite the end of it. If we reboot it, we might get something different. This time it's a black screen. This time looks like that. Black screen. Black screen. Flashing, but slightly different. So as you can see, the issue now is not consistent. Now, to me, that screams PLA. So I'm going to take some readings on the PLA and see what we get. Don't be so smart, Spock. You botched the acetylcholine test. Bonus points for anyone who can put the name of the Star Trek episode that comes from down in the comments. So, like I said at the beginning of the video, I need to get my mojo back, and apparently I lost more of it than I thought. So, when I did the testing on the PLA, I did everything wrong. I had the scale set wrong. I was checking the wrong signals. Now, oddly, I did come to the correct conclusion in the end that the PLA was bad. You'll see that in a minute. But what I decided to do so that we can see the smoking gun is I put the bad PLA back into the board, and we're going to measure it correctly this time. All right. So I have the scope set up, and it's scaled correctly. It's a new scope in case you hadn't figured that out. It's the Regal DH0804, which is a nice little scope and has HDMI output so that I can give you a good view of what's going on. Much better than I could with the old handheld scope. So, the PLA has 16 inputs and 8 outputs. The 16 inputs are listed here on this side in the schematic, and the 8 outputs are listed on this side. So we're going to look at the outputs first, because I think the outputs are probably going to be more likely to be wrong. So what we're looking for is things that are stuck high or stuck low. Now, some of these things should stay high or stay low. Basic, for instance, probably won't have much activity on it. Kernel should have a lot. Character ROM should have a lot. ROM low and ROM high should both be high, because neither of them are selected, I believe, most of the time, and they are active low signals. I/O should be quite active, because I/O activates the CIAs, and the CIAs are used, one of the CIAs anyway, is used to pull the keyboard, so that should be going on all the time. So we're going to start with pin 18 CAS RAM. And this is 15, 16, 17, 18 is CAS RAM. That looks good. It's not getting up to 5 volts, but I often see that with the PLA. So we're getting a good signal there, nothing hovering in the middle. The next pin down, pin 17, is going to be basic. And as I said, there's not much activity there, but if I switch the machine off and back on, there should be a burst right at the beginning. And there was. So that signal looks good. Kernel should be quite active. And it is, and it all looks good. And Char ROM is the character ROM, and it's got good signals. Everything looks good there. Now, over to the other side, pin 13 GR/W. I really don't know what should be going on with that pin, but we should not see any middle of the road signals. Now, I'm not saying it doing anything, but that could be perfectly normal. Now, I/O pin 12. Oh. Well, that's probably our smoking gun right there. Like I said, the I/O pin controls the chip select for the CIAs. It only goes directly from pin 12 here. It goes into, I believe it's pin 1 of the 74LS139. And what the 139 is responsible for is picking which of the two CIAs is activated. So you have two CIAs, you can't have just one signal. The I/O activates the input-output portion, which is the CIAs, and then the 139 determines whether it's U1 or U2. And that's a direct connection. There are no passives in between. So that signal, that little 1 volt signal that's coming off of that, that's either being caused by the PLA or the 139. And because the PLA is a very likely culprit, a very likely cause of failure, and it's socketed and easy to check, we're going to see if we can solve the problem by replacing the PLA. Okay, old PLA out. And it's a little warmer than I would have expected it to be. So that's another indication that there's a good chance it was the failure point. And here's the replacement PLA. This is one of the PLS 100s that I got a large lot of. So a pretty reliable chip going forward to replace the 906114-01 MOS PLA. The PLS 100s were the replacement for the 82S 100s, which were the original PLAs that went into early Commodores. All right, so with that in place, and I'm going to go ahead and get the scope ready so I can take a look at that signal, the I/O signal. But let's see if we happen to get anything good. As we have the capture set up, let's see if we get a picture. And we do. We have a working C64. Now let's take a look just for, well, kicks and giggles, let's say, at what that I/O pin looks like when it's doing what it's supposed to do. Not much, but you see a little signal there. Let's set up a, whoops. set up a better trigger. There you go. Now you can see what that signal is doing. And that's what it's supposed to do. As I said, it has to activate the CIAs on a regular basis so that CIA 1 can pull the keyboard for key presses. And just out of curiosity, since I said I didn't know what GRW should be looking like, let's go to that one. That's pin 13. Oh look, GRW should be doing something too. So that was another smoking gun on the old PLA. That was just a solid high signal with no activations. Let's see if our time scale, yeah, we're getting multiple drops there. So yeah, we had a couple of smoking guns on the original PLA. So that's what that testing should have looked like when I did it the first time. And like I said, I just lost more of my mojo than I thought I had, and did not get any of that right. So what I need to do now is run some diagnostics. I will start with DesTest Full, which is the full 64K RAM test version of DesTest. As far as I know, DesTest Switch isn't out yet, so I don't have a copy of that. I do have DesTest Max, which only tests the first 4K of RAM, but I want to run the full test and see if it gets through that. Now, this test does take a while, so I will speed it along for you. Zero page is good. Stack looks good. Timers seem to be counting up correctly. And there you have it. Fully passed. Now it's running its second pass. So all the memory is good. The ROMs are good. The CIA timers are running correctly. So now we need to run the full diagnostics with the harness. That is this cartridge. I did take the precaution of cleaning the edge connectors, so they should not be an issue here. So let's run it through standard diagnostics with the harness. The SID is in the board, so if the SID is working, we should hear it after the interrupt test near the end. And that is a rare thing in my experience. A SID that's actually working, or at least it seems to be so far. So, one more thing to do here. That's to test some proper SID music with the Easy Flash and Donkey Kong Arcade. And that all sounds good as far as I can tell. So, it looks like we have a working machine. Now, as I said, power level is not quite where I would like to see it. So, ideally, I should go back through this thing and try to find out where the power is having a problem. And so that's exactly what I did. I took the board and I tried to figure out exactly what was going on with it. See what was causing the drawdown on the power rail. I started back at the power jack, checked to make sure I was getting full 5 volts in, and I was. Rechecked the switch even though it was brand new, made sure that it was getting 5 volts and 5 volts were getting through it, and it was. So I began checking the rest of the board, and at that time I was actually getting nearly 5 volts at the user port and nearly 5 volts on the RAM. So I was confused. Why was I getting lower voltages before but not now? So I started poking around, and as I did that, I began to notice that the power level was dropping. Each time I would check it, it would be lower. So I thought, well, that sounds like a thermal issue. Something was getting warm, and as it got warm, it was drawing down the power rail. So I got out the thermal camera, and I checked the board, watched the board as it warmed up, and I found that in U14, the 74LS258, I believe it is, 258, which in this case was actually one of the MOS ICs, was getting quite warm, and logic chips shouldn't do that. So I went ahead and I pulled the MOS IC out of the board. I had to desolder it, put in a socket, and I replaced that with a brand new Mitsubishi 74LS258. And after I did that, I checked again, and the power rail was holding steady at about 4.8 plus, close to 4.9 volts. It did eventually drop a little bit, however, not enough to be a problem. It got down to around 4.7 volts. Target voltage for TTL logic chips is usually 5% tolerance, so 0.25 of a volt plus or minus. They can handle from 4.75 to 5.25 with a little variance beyond that, and that's going to be fine. So let me show you here real quick where we are. This board's been off for a few minutes, so we should be getting the full voltage here. Turn the board on, and we get a display. Checking on the RAM chip. As you can see, well, at the moment we're getting 4.7. Sometimes when I turn it on, I get better voltages than others. Checking again. 4.6. Of course, when I'm going to show you this, it's going to do weird things. What am I getting at the user port? 4.6. There we go. Just a slightly wonky connection in the power jack. So 4.838. That's very good. Now, if you watch slowly, this will tend to drop a little bit. We're down to 4.835, 432, and dropping a little faster there. Now, this is actually kind of normal as the chips warm up. Now, you've got everything from the CPU to the ROMs warming up. The SID and VIC warm up, but they aren't associated with the 5-volt power rail coming from the power supply. They get their voltages to 5 and 12 volts from the 5 and 12 volt regulators on the right side of the board. Voltage is still fine. Now at this point, before I replace the logic chip, this would have been dropping and would have probably already gotten below 4.6 into the 4.5 volt range. Now that was still working. It's just below tolerances for the TTL, and I wanted to get this up to something reasonable. Now see, it does still drop some, but it just doesn't drop nearly as precipitously as it was. So we have dealt with the power issue. So we have one more part that went bad on us. Was a 74LS logic chip. We already had the PLA go bad. The original switch was bad, and I blew I blew a fuse when I was checking on this. When I was trying to check the power jack, I shorted the 5 volts to ground. I think it was the 5 volts. Maybe I shorted the 9 volts to ground. In either case, I popped the fuse, so I had to replace that too. So that's our carnage from this board. And that being said, back to original me. Like I said, I did this repair just to try to get some of my skills back and remember some of how I do this so that I can move on to other projects. This particular C64 is working. I need to finish cleaning up the case and the RF shields, and I think I need to write the case a bit. No, actually, I think the case's color is pretty good. So I need to clean it up and get it back together, and then we'll be done with this one. So the big question is, did I get my Mojo back? And I'm afraid the answer is not completely. I did make a few mistakes. For instance, after testing the power, my next step on a board with a black screen should have been to check for good reset and clock. I didn't do that. I also completely botched testing the PLA. Just because I came to the right conclusion and then corrected my technique after the fact doesn't excuse it. I did, however, get the board fixed in the end, and I managed to refresh my memory quite a bit. I think I'm ready to move on to my next project. And this one's a doozy. I'm going to be refurbishing a machine that I have never owned and have barely ever used. Yep, I'll be losing another one of my retro virginities, so be on the lookout for that one. In fact, if you want to make sure you don't miss it, go ahead and subscribe to my channel if you haven't already. Then click the little bell to turn on notifications so you're alerted when I post new content. I know this wasn't a very interesting fix, but it had to be done. So if you happened to enjoy it, go ahead and smash the like button. It really does help me out. And if you have any thoughts on this repair or just want to chat, feel free to leave me a comment below. Finally, if you enjoy this type of content and want to see me keep going, I do have a Patreon account where you can sign up to support me and get some perks. The link for that will be in the description. Or if you prefer, you can join the YouTube channel membership by clicking the button below. Well, that's it for today. I'm glad to be back making content for you guys, and hopefully it'll be coming a little more frequently now. So be happy, stay safe and healthy, and we'll see you in the next one. Bye.